Hello, this is Mr. Henry, and this is a short little clip on division of exponents. So this is also during that little mini book on the exponential properties, and you probably got to the page where you're talking about division of exponents, and you may not know what to do. Now you can always look up videos on Khan Academy or even just YouTube, for that matter, if you don't understand this video to a great degree, because I'm sure there's lots of videos out there on it, but I'll do my best here in a couple minutes. So basically the way division of exponents works is it is the opposite of multiply, right? You know how like multiply and divide are opposites of each other when you're solving an equation, and add and subtract are opposites of each other? Well, it's the same deal. If this was m cubed times by m to the sixth, if we were multiplying, the thing we would have done using that PMA property, since this is a multiply, we would add those exponents together and get m to the ninth. But that's not what we're doing in this video. That's not what we're doing in this lesson. We're doing the opposite of both of these. The opposite of multiply is divide, and the opposite of adding the exponents together is actually subtraction. Literally what we're going to do is we're going to take m to the third power, and we're going to subtract the bottom exponent. Take the top exponent minus the bottom. That gives us m to the negative third. That's it. That's the whole problem. Now, eventually when you get to the time where you're talking about negative exponents and we want to solve problems with, or write our expressions without negative exponents, well then we're going to have to do something with this. And if you don't know, this will become, you move this piece over the fraction bar, move it to the denominator, and it becomes 1 over m to the third. But that's not the point of this video. The point of the video is to show you take the top exponent minus the bottom exponent, and that gives you this. So if I have here again, next example, g to the eighth minus g to the third, that gives us g to the fifth power. This is the simplified version of that. It is g to the fifth power. Next one. Here we have h to the fourth minus, well, this, when you don't see a power, means it's 1. So h to the 4 minus 1, and that's h to the third. And actually, I don't like how I wrote this. I'm going to go back. This should not be a little g in here. This should be like I wrote the other one. It's 8g to the 8 minus 3 power. 8 minus 3. No extra g in there. Okay, and the bottom one, or the last one here, I'm going to actually change this up. I want the 5 on the bottom. So if I put the 5 down here, 2 up top there, if I do this and take k to the 2 minus 5, top minus bottom, gives us k to the negative third power. And we do the same thing we did in the first example. We take this, put it over a fraction bar, and when you move this piece over the bar, you get 1 over k cubed. So if you think you got that and you're good with that, you can stop the video right here and move on. I'm going to show how I do it. This is not really how I do the problems. This is a good way to do it that it uses the properties. There's absolutely nothing wrong with it. It's just not my way. So let me show you my way for those who want to see. I'll leave everything else the same. Alright, here's my way. When I do this, we are still subtracting. But basically, I subtract to wherever the bigger number is. So here, I have 3 m's up top, m, 6 m's on the bottom, 1, 2, 3, 4, 5, 6. And so when you start subtracting, if I take away 1 m here and 1 m there, 1 here, 1 there, 1 on the top, 1 on the bottom. Well, I'm out of m's on the top to cancel out. So that means my answer is, I've got m to the third power on the bottom, and there's nothing up top, we put a 1. because when we're canceling stuff out, we're dividing stuff. Anytime you take a number divided by itself, you get an answer of 1. So this is the same answer we got before, but we didn't have that negative exponent, and I personally like this better. So I would subtract the smaller number from the bigger number, and the answer goes where the bigger number is. So here, I'm going to take 3 minus the 8. I'm going to move up because this is the bigger number. And 8 minus 3 is 5. G to the 5th power. Same answer we got before. Here, take the smaller number and subtract it from the bigger number. So I'm moving it the 1 to the top here, and I get h to the 3rd power. Here, smaller number goes down to the bigger number to subtract, and I get, well, 5 minus 2 is k to the 3rd power. Oh, no. 1 over k to the 3rd power, because this moves down to the denominator. So I need the k to the 3rd in the bottom, and then the numerator is just going to be a 1. Same answer as I got before. All right. Now, if you like this one, stop. Move on. Fill in your booklet. If you like the property, use it. I'm going to show one final option. This is a way that Mr. Dunkelberger likes to do this. Or at least that's what he told me last year. He likes to do this. So let me erase all this stuff, and I'm going to show you the method that he likes, and then that will be the last one. So here's what Mr. Dunkelberger likes to do. If he has exponents on the top and the bottom, he likes to just kind of get everything together and then worry about the math. So what he would do, what he talked about doing, is taking all the stuff on the bottom and just moving it up top. So worrying about like the negative exponents. So this, if you move this m to the 6th up top, becomes m cubed on the top, stays there, times by an m to the negative 6th. When you move an exponent across a fraction bar, you change the sign of the exponent. And now, these two powers are being multiplied together. So the PMA rule says, if they're being multiplied together, you will add the exponents. 3 plus negative 6 is negative 3. And then you can worry about changing your exponents, this negative exponent, to make it back to a positive, and it's still 1 over m to the 3rd. Just a slightly different way. And you might find some of these times it's easier, sometimes it's harder. This next one, I think it's a little bit easier. If you move this guy to the top, you'd get g to the 8th times by g to the negative 3rd. It's negative because it's when it's positive on the bottom of the fraction, it's negative on the top. Now, using PMA, because these two powers are being multiplied together, you add the exponents and you get g to the 5th. And this one, if you move him up, is h to the 4th times by h to the negative 1, which gives you h to the 3rd. And here, if you move this guy to the top, you have k squared times by k to the negative 5th. Because the powers are being multiplied together, you add the exponents, you get k to the negative 3rd. And then using your negative exponent property, we're going to move this guy to the denominator of the fraction, because right now it's at the top, and that, okay, and I get 1 over k cubed. So hopefully out of those 3, you found one you liked. So you can go ahead and fill in the rest of your mini book. This has been Mr. Henry, and again, if you didn't like any of these explanations, you're on the internet. Go look up Khan Academy. Go look up YouTube. Go find somebody else who has a better description of how to divide exponents that you like and use it. Thanks for watching.